Okay, well, let's talk about E. Yes, just when you thought you knew about all the variables that actually represented numbers like pi, being 3.14, well, now we bring another one to you, and that is E. And E is a number that is just about 2.7 something, 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 something. All right? The calculator recognizes this number, and we do too. So, but at first, we can work with E just like it's a variable. So if I said, what's E squared times E to the fourth? Well, that's an add exponents property, and you'd get E to the sixth. Down here, we would get, well, this is really a 1 here, so we take the 3 times the 1, and then we'll take negative 2 plus 6, and we'll get fourth. So that'd be 3e to the fourth. Here, we've got a negative exponent of negative 2. We have to apply it to the 100 and to this. So that's going to be 100 to the negative second power times e to the, let's see, what's half of negative 2? That'd be negative 1 x. And so how do you make negative exponents positive? Well, you take them to the denominator, and that's going to give you 100 squared, which is, that's going to be what? A 1 with 4 zeros after it? And you get that. The cube root, well, cube root means we need to take the cube root of, it's really like having an exponent of 1/3, right? So this will be 6x times 1/3. Well, I know what the cube root of 27 is. It's 3. And this is going to end up being 2x, right? Because 6 over 3 is going to be 2, all right? So the first section of this, you're just applying the properties of exponents, all right? And we can do that with E. Then they're going to actually say, okay, use a calculator and figure these out. And so I'll find my E button. It's on my calculator. And I'll take it to the third power, and it's going to tell me that that's 20.008555, and it never stops, and so I'll just put it at 3. Okay? E to the negative 1/4. Well, I'm literally going to go E, and then I'm going to put parentheses 1 divided by 4. Notice I didn't say negative, right? And I get, that's 0.67. Okay, so really, if this is equal to 0.67, it's still to the negative, there's a negative power there. So it's really 1 over 0.67. And that's 1.493. Okay, depending on where you want to round it off at. If I actually put the negative in there with this, let's see if I get that same answer. E to the negative 1 divided by 4 power. Ooh, I got a different answer. Yeah, I think, Yeah, well, it shouldn't be negative. I don't think that should be negative. Okay, so what I've done here is, this is wrong. Okay, we're going to get rid of that. E to the 1/4 power, and I don't know why my calculator said that, e to the 1/4 power is 1.28. And then when we take that and make it negative, then we get 0.7788, and that's what the right answer is, okay? Then if we take negative 1.2 times e to the 5th, well, I'm going to do my e to the 5th first. That gives me about 148, and then take that times the negative 1.2. And that should give you like a negative 178.096. Okay? So you were using the calculator to come up with those answers. Not a big deal. All right. Now, we want to know if this is growth or decay, okay? And the A value is going to be important, but probably even more important is going to be this R value. We call this, because we're going to run into a formula here pretty soon. We're going to call it PERT. And this stands for principal, this stands for rate, and this stands for time. Principal, another way to say principal is initial value. And then this is just the E number that we know. So if we look at this, this is a negative rate. And what that's going to give you is a graph that is one of exponential decay. Okay? So if this R value is negative, we're going to have decay. All right? Here, our R value is positive, and so this will be an example of exponential growth. All right? Hope that makes sense. And then the last problem here, number 36, this is what we refer to as continuously compounded interest. And here's your formula. It says the amount in your account will be the principal times e to the RT power. I call it the PERT formula. All right? And so what if you make a $975 deposit at 5.5% for 6 years? So there's your R, this is your T, and this is your P. And you fill those in, and then we're going to figure out, first thing we're going to do here is what is 0.055 times 6? That's 0.33. Then I'm going to find out what is e to the 0.33 power. That's 1.391. Take that times 975, and you'll wind up with $1,356.19 in your account after 6 years. Put $975 in at 5.5% interest for 6 years. If you continuously compound, if it's compounded continuously, you'll have $1,356. All right? Hope that helps.